we are doing linear momentum. Linear momentum, according to Newton's second law of motion, for a system is defined as mass times the time rate of the linear momentum of a system, which is equal to the sum of the external forces of the system. In fluid mechanics, this equation is modified in order to calculate the linear momentum of a fluid system by observing the control volume of a system. Real-life applications of linear momentum in fluids. Control volumes are needed to solve for linear momentum problems in fluid mechanics. The Reynolds transport theorem is used to convert a system analysis into a control volume analysis by finding a parameter of interest. Applications of linear momentum is usually used to determine the anchoring force of an object holding the fluid. The purpose of this experiment is to demonstrate the concept of linear momentum. In this experiment, we will be demonstrating one type of collision that could occur in a linear momentum, which is elastic, which conserves kinetic energy. Our materials that we use for this experiment is a water balloon, a water, and a tennis ball. These two videos showcases an aerial view and a front view of the tennis ball and the water balloon, both basically dropping down onto the table. And as you could see the impact of the water balloon and the energy and everything pushing from the impact going back up and pushing the ball back up, which is kind of like conserving energy and moving momentum at the same time. So here is an aerial view, so you can see. And here is our front view, which is a little bit better of a view. There goes all that force hitting back up onto the ball, which pushes the ball further up. Our data and calculations. Our objective was to use the linear momentum equation to calculate the height of the tennis ball and how high it would travel. Our assumptions is the balloon is a perfect sphere with diameter of 6 inches. We neglected air resistance. The control surface is equal to the middle cross section of the sphere balloon, which is showcased right here at the right side. We neglected the weight of the balloon, and 50% of the force from the balloon will be transferred into the tennis ball. Here are more of our calculations. We calculate the velocity of the balloon to impact using this equation. Here are our values. Here's the volume of the balloon, which we got 0.06545 feet cubed. Here's the mass of our balloon, 0.127 slugs. The area of our impact whenever the balloon and the tennis ball hit each other, which was about 0.1963 feet squared. The sum of the vertical forces using control surface, which about 12.2625 pounds force. We had a negative because we assumed that upward was positive, so whenever we dropped the balloon and the tennis ball down together, that was the indicating the direction. And the force acting on the tennis ball was 6.13125 pound force. The weight of our tennis ball was about 2 ounces, which equals 0.125 pounds. The mass of the tennis ball was about 0.00388 slugs. And assuming the force of the balloon is imparted to the tennis ball over 1 inch, which was about 0.0833 feet, we found the velocity of the tennis ball after the impact using the sum of the forces using kinetic energy. And we got 16.2254 feet per second. And after that, we could solve for the height of the tennis ball using this equation. And the final height that we calculated was 4.088 feet. Here are all of our sources. Thank you so much, and go Jags.